This course is basically for BSMS students of NIT Nagaland during the lockdown period. So dear students, as I've promised that we'll be basically starting off with this, and before I start with this, let me just give you a brief of how we are going to go about with the syllabus online. So as all of you have already seen that we are using the tool of Google Classrooms, and you have this unit 4 different power plants chapter. I have already uploaded some reference material yesterday, and today I'd be uploading the first lecture. So let's just start with the presentation. It's going to be a very basic introduction about the power plants right now. So what we want is we want to know about different power plants in this particular chapter, and the first lecture is on the introduction to the power plants. So the syllabus only for this unit mainly deals with thermodynamics, which is applied to thermal power plants. So next we have got the nuclear power plants. We're going to see about nuclear power plants. We're also going to talk about solar thermal power plants. These topics are very vast in itself, so we are not going to go into too much detail, but that will be more than enough for a basic introductory course, because this forms only a part of your unit and it's not the entire syllabus. We also are going to talk about geothermal power plants, and then we are going to talk about the introduction to the constraints that are currently placed on power generation plant. We are going to talk about low emission systems, measures to improve the efficiency of a power plant, and finally the instrumentations that is needed in power plants. Probably instrumentation part we can study a bit early also, because we need to know that what are the different instruments that are basically needed in a power plant. So when we talk about thermal power plant, all of these power plants, usually if you look into any kind of image, you will look similar. But if you look into a thermal power plant, this is the image is taken from Wikipedia. This is a thermal power plant, and this is basically a power station in which the heat energy is converted into electrical power. So we have the electric power, and which is actually obtained from the heat energy, and that's why the term thermal. Next we have got what we call as the nuclear power plant. In the nuclear power plant, obviously the nuclear fuel is the source, so you basically need a fuel there. So before this, when we talked about the thermal power plant, we talked about heat as the source of power, and a nuclear power plant, we are talking about the nuclear energy. So it's basically a thermal power station in which the heat source is a nuclear reactor. So we have the heat source, which is a nuclear reactor. Next we have got a solar thermal power plant, and then basically takes up the solar energy. So a solar thermal power electric generation systems collect and concentrate sunlight to produce the high temperature heat needed to generate electricity. We talk about solar thermal power plants. Solar energy is not something which is not known to you. Already know a lot about these things, but since we are talking about power plants here, so the scale at which these designs are made is very large. So we have a huge region where the solar panels are put up for the generation of heat and conversion to electricity. Next we have got the geothermal power plants. So now these are basically something which is more natural, because there are some geothermal energy sources. It basically arises from the temperature gradient that occurs from the relatively cool surface of the Earth's crust to its extremely hot core. So in case there is a difference in temperature between the surface and the core, we are going to get some kind of energy generated, which we basically call as the geothermal energy, and that is also a byproduct of heat energy. So that's the term we are using, which is geothermal power plants. So a power plant basically is an industrial facility. It's not that can be built in your backyard. We definitely need a lot of resources for this. A lot of finance is needed for this. So it's basically an industrial facility which is created with the aid of government and some private firms, and it generates electricity from primary energy. So this primary energy is important and plays the role to generate the heat. Now the type of fuel or the flow that provides a power plant, its primary energy varies. So the type of fuel that we basically use, or which actually powers the power plant, will actually vary, and based on this we have got different category. Now the most common fuels that are used are coal, natural gas and uranium. So if you're basically considering a nuclear power plant, you're basically using uranium. In thermal power plant, coal is used, natural gas is used, and so on. But we need to note that these are all non-renewable energy sources, so we need to take care that how and when they are generated and then optimum use. So probably this is also important, this chapter, because in case tomorrow someone designs a power plant, he has to design an optimum system to minimize the loss of fuel. So a substantially used primary energy flow for electricity generation is basically hydroelectricity. So hydroelectricity is something which is very common. So we already have power supplies throughout the nations using the water as a primary source of energy, and we are also going to see that what's the status in India and world for use of different kinds of sources of power plants. The other flow that are used to generate electricity include wind, solar, geothermal, and tidal waves. So if you talk about geothermal and tidal waves, the source is actually minimal in number. So we don't have that many sources in and around us. So it cannot be exploited that easily. So that's there. Okay, let's have a look into this image. We are going to go into more details of this image, but before that, if you look here, this is basically a world picture. That's the world map, and then we have got the world electricity generation. Now this is as per the 2015 census. The requirement or the production was in terms of terawatt hour. So when we studied the chapter of battery, we already had the concept of watt hour, ampere hour, and so on. So you can refer to that to understand these terms. But just to give a brief and look into it, we can see that coal and coal products are something which is contributing 39.9% to the power supply. Okay. So before we proceed further, let's just look into the picture of India. So what you can do is you can go into this web page, which is basically energyeducation.ca, encyclopedia oblique power plant. And if you go there, you can actually look into this, the world electricity generation. And we have got the picture of the world. Now let's type India. So you can basically type India, or you just look into the map and click here. So we just click here, we have the subcontinent region, and then we can click again, and then we have got the Indian image. So once we have the map of India, we can basically look into the use here. What you see is that coal, if you tap on coal, you can see coal and coal products produced around 75.3% of power, so in terms of terawatt hour. So that much energy it has generated. We have got the hydropower, which is the next, which generated 10% in Indian power plants. And then we have got natural gas, which is 4.9%. Solar and wind is something which we want that it should go up, it should rise. Right now the use is only 3.5%, and compared to, globally, to some of the developed countries, this is much less. If you look into the nuclear power, it's only 2.7%. We know the nuclear power plants which are situated in Kalpakkam and some other places. And then we have got the biofuel and waste, which should also be encouraged, because this actually talks about an energy source which might sometimes be renewable, because waste is something which you are not using, and if you can use it for some purpose of generating electricity, that is something which is very much desirable. And then finally the oil products. So most of them are non-renewable sources, except solar, wind, and waste that we're talking about. So that way you can actually explore this. You can type, let's check USA here. So if you check USA here, we don't have that. So let's say okay, United Kingdom, United States, there it is. Okay, let's take United States. So we look into United States, we can see that natural gas is 31.9%. What is interesting to see is the nuclear power plant use is actually 19.3%, and solar power is also 5.4%. Not much higher than India, but still comparatively it's better, and so on. So if we just proceed with the presentation again, and what we can see now is the graph here, where you can see that the energy need and the energy generation is growing day by day. In 2015, the need is quite high from coal, or the production is very high using coal and coal products. So as we are going high, further and further along the timeline, we can see that the production is high because the need has definitely increased with growing of industries and so on. So what are the power requirements basically? So if we look into the report of the International Energy Outlook in 2010, the world net energy generation projection increases by 87% from 2007 to 2020. So if in 2007 the need is 18.8 trillion kilowatt hour, the same need in 2020 would be 25 trillion kilowatt hour. So today in 2020 the need is 25 trillion kilowatt hour. Definitely there is going to be a very minor change because this month we are all under lockdown. But if we continue further and we look into a picture 15 years later, the need is 35.2 trillion kilowatt hour. So again, that's very high. So the rate is increasing enormously. So although the recession has slowed down the rate of growth in electricity demand in 2008 and 2009. So if you remember, 2008 2009 was actually under the problem of global recession. But then by 2015, the pre-recession rate has come back into the picture because that age when there were jobs which were less in number was past, and 2015 again saw a surge in demand of electricity. Now, if we look into the forecast of the world net electricity generation from 2007 to 2030. So if you look into this, it's in trillion kilowatt hours, and the graph is self-explanatory. You can just check the graph and look into this, and you will understand that what's the exact picture. We look into 2035, same as said in the previous slide. We have the demand which is growing more and more, and then we are expecting the black bar. That means it should generate from nuclear power. There should be renewable source. There is natural gas, coal, and liquid. More and more non-renewable sources like solar and wind should definitely be encouraged. Now, most of the world's electricity is produced at thermal power plants, so that's the maximum use, which uses traditional fuels like coal, gas, and fuel oil. Now, that's up to 20% of the world's electricity is produced by hydroelectric power plants. So we have got the thermal power plant on the forefront, and then we have got the hydroelectric power plant. Now, in countries with well-to hydropower, the figure is much higher. In fact, the hydropower is much more in countries like Norway, where 99% of its power is generated from hydroelectricity. And then we have got Brazil for 92%, Austria, Canada, Peru, and New Zealand over 50%. There is a term which we basically call as performance index, and we basically write it as OEE, and it's availability multiplied by performance multiplied by quality. So these three factors actually affect the performance index. In other words, if you are saying that we are using hydroelectricity more, that means the performance index for hydroelectricity is much higher. What do we mean by availability here? Availability basically refers to the process, the equipment being available for production when scheduled. So if we are basically going to produce hydroelectricity at this moment, do we have the instrument, do we have the production facility? That's the first factor. Now, the performance is determined by how much waste is created through running at less than optimal speed. So in case the system is not running at an optimal speed, we expect the waste should not be much. So that is what the performance deals with. And finally, quality focuses on identifying time that was wasted by producing a product that does not meet quality standards. Now, this is quite simple. If you are producing a product, in this case hydroelectric power or the electricity, and that cannot be used because it doesn't meet the standard, you have already wasted a time which is very valuable, right? So that is what quality determines. So you should not be wasting that time on substandard material or substandard output. The efficiency of power plant is again very important. Now, the performance of the thermal power plant can be represented by its efficiency. So in general, we know that efficiency is nothing but output divided by input. So if we talk about the efficiency of power plant, the ratio of its electric output to the amount of heat used. So you are giving heat as an input. So heat is the supply. So that's the input. and if you take the ratio with the electrical output, we're basically getting the efficiency which is represented in percentage. Now if you use a commercial power plant, the range will actually be from 30 to 65%, and the more efficient plants cost more to build. So if you need a very efficient plant, let's say 65% efficiency, the cost would be much more compared to a plant which can give you an efficiency of 30%. The efficiency depends more on how the energy is used rather than how it is produced. Okay? So we can have the production, but it's also important how is that end product used, because rating are based on conversion of heat to electrical power. So the loss should be minimal. If too much heat is lost, the conversion to electric power would be much less, and obviously the efficiency will come down. So that's all for today. We are going to continue with this in our next class. In the next lecture, we are going to proceed with some more specific power plants.